This is going to be a lesson that shows you how to use Pascal's triangle and the binomial theorem to expand binomials and to find specific terms in the expansion of a binomial. First, we're going to do a warm-up using the fundamental counting principles and permutations and combinations. So go ahead, pause the video and try the warm-up. So you should have tried this on your own using the counting principle. Find the number of outcomes. So we have two choices. We have the type of flower, and there are 3 types, and there are 4 colors. So that means there are 12 possible outcomes. Draw a tree diagram and list the sample space. So we have 3 choices for flowers. We have roses, we have zinnias, and we have cosmos. And those can be yellow, red, orange, or purple. Now, just for space, I'm gonna kind of yellow, red, orange, purple, yellow, red, orange, purple. List the sample space. So here we go. I could have yellow roses. I could have red roses. I could have orange roses. I could have purple roses. I could have yellow, orange. Oh, that is really, I just massacred that. We'll just go back to red. Yellow, red, orange, purple for zinnias, Z-I-N-N-I-A-S, Z-I-N-N-I. And then I could have yellow cosmos, red cosmos, orange cosmos. Why can I not spell orange? Or purple. So those are the 12 items in my sampled space. Find the probability that a yellow flower is chosen. So I have 1, 2, 3 options for yellow flowers out of my 12 total options, or you could write that as 1/4, or you could write that as 25%. Find the probability that a zinnia is chosen. Well, there are 4 out of 12, or that could be 1/3. That a red rose is chosen is 1/12. 8 children stand in line to play a game. How many ways can the children be arranged? So when I line up the kids, the first option, there are 8, then there are 7, then there are 6, 5, 4, 3, 2, 1. So the other way you could write this is you could write this as 8 factorial, or you could write it as 8p8 on your calculator. Either way, when you put that into your calculator, you should get 40,320 ways the children can be arranged. License plates in Hawaii are 2 letters followed by 3 numbers. How many license plates are possible if I can repeat them? There are 26 letters, so 2 letters, and then there are 10 digits. Remember, it's like 0 to 9. 1, 2, 3. And if I put that in my calculator, I get. Okay. Now, wait, whoops, I put the wrong one. That's wrong. That's the next answer. Looking at my notes wrong. All right, so when I put this into my calculator, I got 676. Okay, so if they cannot be repeated, so like once I pick a letter, that letter comes out. So now I only have 25. I have 10 digits. I've used one. I have 9. Then I have 8 because I can't repeat them. That one is going to be 468,000. And last in the warm-up, number 4, a specific program requires the user to enter a 5 alpha-based password. Letters cannot be repeated, and so we're only picking from 1, 2, 3, 7 letters. So I'm going to make a password. I have 7 letters, and I'm going to choose 5 of them, and order matters. So you could think about this as 7p5, or 7 times 6 times 5 times 4 times 3. Either way, you will get that there are only 2,520. If you just need a reminder of how to use your calculator, that's going to be, first I'm going to type the 7. I'm going to go to Math, PRB, and I'm going to pick number 2. Boop. Okay, so let's get into today's lesson. So first off, we need to familiarize ourselves with some common notation. I want you to make a note in your packet that the symbol N over R, like this, is a combination, NCR. Okay, so whenever you see that, you know that that's the same as out of N values, you are selecting R, and order does not matter. So let's just toss these into our calculator. I'm gonna do them all at once. So I've got 3 math, and 1, and there's only 3 because I'm picking 1 of each. 4 math, so 3 6, and then 8 math, 7. So there are 8. So if you think about it, if I pick 7 of the things, then there's only 1 left over, order doesn't matter. So the 7 ways to do it is to leave 1 of each of the original 8. So those are some calculations. Now we need to take a look at something called Pascal's triangle. And what we're going to do is we're going to combine Pascal's triangle with our knowledge of combinations to develop something called the binomial expansion. So Pascal's triangle starts with the number 1, and then there's another 1, which is these 3 ones, if you will. And the way Pascal's triangle works is that it adds together 1 plus 1, and it makes 2. And then these ones here and here are added next to the 2. Now, 1 plus 2 is 3. 2 plus 1 is 3. And then again, these ones are added. And we keep doing this. We keep adding ones down the outer diagonals, and we just add together. 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 is 4. Add the ones. 1 plus 4 makes 5. 4 plus 6 makes 10. 6 and 4 is 10. 4 and 1 is 5. Add the ones. And this is Pascal's triangle. Well, what happens is, as we expand a binomial a plus b or x plus y, the coefficients of our expansion can be found in this triangle. Let me show you what I mean. If we have anything to the 0 power, that's just 1. If we have x plus y to the, to the first power, that's just 1x plus 1y, because I only have 1 of them. So now here, if I've got x plus y squared, and I multiply out x plus y times x plus y, I get x squared plus x y plus xy plus y squared for multiplying, and I end up with 1x squared plus 2xy plus 1y squared. Here are the coefficients in the third row. So really, this is like the 0th power, the first, the second, the third, and so on of expanding. So what is required when using Pascal's triangle if you want to expand x minus 3y to the 7th power? So let's see, we have the 0, 1, 2, 3. Here's the 4th. Here's the 5th power. So we would have to go 2 more out. So if we did that, we would need this, we would need the 7th row. Or like, it's not, I guess, like, I don't know if you want to think about like the 8th row, but I need the coefficients. So let's find them. I've got 1, 6. I'm just adding 6 plus 10, or sorry, 5 plus 10, 10 plus 10, 10 plus 5, 6, 1, and this would be for the 6th power. And now for the 7th power, make them green, I would need 1, 7, 21, 5, 35, 35. So I would need the coefficients here. That's what I would need. Or instead of expanding all of this out, I could do 7, choose 1. I could do 7, choose 2, and so on. Let me show you with the calculator. If I do 7, 1, I'm gonna have, there's, oh, whoops, sorry, I start with 0. And that would be the 0, that would be 1. And then here's 7. And I bet if I do this one, I'm gonna get 21 because that's the next number. Let's watch, calculator. I'm gonna just do second enter and then change that to a 2. Yep, 21. Now I bet if I change that to a 3, second enter, change it to a 3, sure enough, it's 35. So I can use combinations and I get the same values from Pascal's triangle. So what this leads us into is the binomial theorem. Whoop, I don't know what this is. Fancy. Where's the binomial theorem page? Oh, here it is. Okay, so let's just fill this in real quick. So if I've got, this is 2, this is going to be 3, 3. And I guess they want you to use combinations, but it's kind of easy just to add. I don't really know why you would use combinations if you can just add. But okay, so here is the binomial theorem. If we have x and a be real numbers, so x is the first term in the binomial, jot this down. A is the second term in the binomial. Then what we can do, and you can see this is really long and complicated. I'm going to write this out for you a little better. We can find any term starting with the 0 term, starting with term 0, we can find term, we're going to call it R, and it's going to be NCR, and then we're going to have x to the n, a to the n minus r. Okay, so what we're going to do is we are going to use the binomial theorem to expand x plus 2 to the 5th. So x is our first term, 2 is our second term, 5 is our n value. Everyone make sure you jot this down. The first thing we want to do is, what is the first term? What is the second term? How many, like, what's our highest n value? So what we're going to do, and I'm going to do this kind of like across, because I think it goes better. Like, I'm going to do it, I'm not going to, you'll see. I don't know why I'm getting myself all tangled. I'm going to start with r equals 0. So I'm going to say n c 0, and I'm going to just set myself up all the way up to NC1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. So we always are going to go from 0 to n. So whatever this value is, you should have one more term. So now, x to the n, our x value is just x. So that's easy. X to the n. Oh, wait, I forgot something. Guys, I screwed up. Don't be mad, okay? Erase. This is n minus r and a to the r. So make sure we fix that. I'm going to put like a highlight around it. Okay. So here, remember, this is n. This is r. So our first value is an r of 0. So we have 5 minus 0, 2 to the r. So on my calculator, I'm going to do 5, choose 0, which I know is 1, but just for funs. 5, math, 3. Yep, it's 1. Oh, I forgot the 0. I hate you. Calculator. There goes. All right, so 5 choose 0 is there's only one way to do that. So I'm going to switch colors. So that gives me, so this gives me 1. 5 to the 5, or sorry, x to the 5 minus 0 is x to the 5th. 2 to the 0 is 1. So my first term is just x to the 5th. Not very exciting. So now on my calculator, if I do, well, let me get set up first. I'm going to have x to the n minus r, second term to the r. And I could set this up all the way down, but I'm going to do them one at a time. So first, I've got 5 choose 1, which I know is 5. So here I've got, this is 5. And then I've got x to the 4th. 2 to the 1st is just 2. So I'm going to have 10x to the 4th. So now, remember, this is very systematic. I'm going to go through 5. R is 2 now. So I'm going to have x to the 5 minus 2 times 2 squared. So let's see. Second enter, just change that to a 2. I get 10. So this is going to give me 10. 10 times x to the 3rd. And then I know that 2 squared is 4. 10 times 4, I have 40x to the 3rd. I'm going to just keep going here. I'm actually going to now fill these in. So this is going to be x raised to 5 minus 3, 2 to the 3rd, x to the 5 minus 4, 2 to the 4th, x to the 5 minus 5, 2 to the 5th. So now I can go on my calculator and do 5C3, and I know that that's 10. So I'm going to do all these first on my calculator off to the side. So I get 10, 5, and 1. Now I have these x to the n minus r. So this is going to, I don't know what the green. So I'm going to have x, hey, purple please. Thank you. I'm going to have x squared. 5 minus 1 is x to the 1st. Now here, 5 minus 5 is x to the 0, and x to the 0 is just 1. So now I'm going to multiply times 2 to the 3rd times 2 to the 4th times 2 to the 5th. So I end up with 80x squared, 80x, and 32. So here are my 6 terms. Remember, whatever your power is here, you're going to have one more than that. So my final answer is going to be x to the 5th plus 10x to the 4th plus 40x to the 3rd plus 32. Now, you're going to be like, this is a lot of work. Why would I do all of this? Well, let's look at the alternative. The alternative would be to multiply x plus 2 5 times. So these two become, that's not a big deal. That's just x squared plus 4x squared, 4x plus 4. But then as we start multiplying these polynomials are going to get very long. It's going to be really easy to make a careless mistake. So you can see that the binomial theorem, while it does seem tedious, is going to give us a more accurate answer than doing all this multiplication. The binomial theorem is also helpful because in addition to helping us expand out a whole binomial, it can allow us to find a single term. And that's what we're going to do next. So now we want the coefficient of y to the 5th in the expansion of 2y minus 3 all to the 10th power. So what I want you to do is I want you to pause the video and I want you to fill in as many of these as you can. Fill in as many, so you've got 4 values, fill in as many as you can, and then unpause the video. So here's how we can find any individual term. And hopefully you were able to say, all right, well, I know that n is 10 because that's a 10. I know that r is, I don't know yet, we'll get to that, but hopefully everyone got x is 2y because that's the first value. And the second value here is -3. So I hope everybody got those. So now the question is what r value do I need if I want y to the 10th? So I'm going to think to myself, okay, I have 2y raised to the 10 minus r times -3 to the r. Now I'm going to get no y's here, so I don't have to worry about this -3. But let's think for a second. What does r need to be on this expression that I'm going to highlight? What does r need to be to get y to the 10th? If you said 2, you're correct, because what's going to happen here is when we have 2y to the 10 minus 2, if r is 2, then we're going to have 2y to the 8th. And then I'm going to have to raise 2 to the 8th, and y to the 8th gives me y to the 8th. And that's how I know I'm going to use an r value of 2. I'm going to go through that again. I think about my x value, 2y, times raised to the power of n minus r. So 2y raised to 10 minus r. I think of my a value, -3 raised to the r. And I realize this isn't going to give me any y value, so I don't need to worry about it. Cross that guy off. Here, what r value does this need to be to make it y to the 8th? So I think, well, if it's 10 minus a number and I'm going to get y to the 8th, then it's going to have to be r is 2. That way 8 minus 2 is, or sorry, 10 minus 2 is 8, and I can just get y to the 8th. So now I'm going to go ahead, I'm going to switch pen colors, and I'm going to say 10 C2 first term to the n minus r, second term to the r. I'm just finding that single term. So I'm going to do 10, choose 2, I get 45. Now, I don't know what 10 or 2 to the 8th is off the top of my head. So I'm going to go ahead and just write this down. 2 to the 8th, y to the 8th, and I have -3 squared. Now I'm going to get out my calculator, and I'm going to say, okay, 2 to the 8th. Ooh, that's a big number. So I've got 45 times 256 times y to the 8th times 9, because -3 squared is 9. And now I'm going to multiply all of these together, and I get 103,680 y to the 8th. And the question is, what is the coefficient? So the coefficient is just the 103,608. So there's a problem where we're asked for a specific coefficient. Example 3 is asking us to find the third term. Now we need to be really careful with this. The third term is not r equals 2. Because remember, we start, let's everybody right now, pause the video, write down n, x, and a. Just write down those 3. Pause it and then unpause it. Okay, hopefully everybody wrote down n is 4, because 4. X is 2x, because there's a 2x here. And a is 3. If I want the third term, really the first term is going to be 4 choose 0, and then 4 choose 1, and then 4 choose 2. So my r is going to be 2 to find the third term, because I start with the 0th term and I end with the nth term. So I'm going to say, okay, I've got 4, choose 2. I'm going to do that on my calculator in a minute. And I've got 2x raised to the n minus r times a to the r. So now 4, choose 2, 4 is 6. So this is 6. So now I want to be really careful here because it's 2x squared. So I have to remember to square, not just make it 2x squared, like it's 2x, math pause, squared. So square the 2, square the x, and then here 3 squared is 9. And so then I'm going to do 6 times 4 times 9, and I'm going to get 216 x squared is the third term. So on the homework tonight, I want you to actually start with number 3. I'm going to help you out. I'm going to help you find the R values in numbers 3 and 4, just to get you started. So we're not doing 1 and 2. All right, so we are looking for, first off, the coefficient of y squared. So we're going to start the same way. We need n, we need r, we need, x, and we need a. So you should be able to find everything except r on your own. Pause the video. Okay, hopefully everyone sent n is 5, x is actually 3, a is actually y. Let's remember our formula is NCR x raised to the n minus r, a to the r. That's our magic formula. So here we go. We're going to say we've got 5c, I don't know what r is, 3 raised to the 5 minus, I don't know what r is, times y to the r. Ooh, once I write that down and I see that I'm looking for x squared, it's very obvious here that r is how much? If I'm looking for y squared, I think I said x squared, I'm sorry. If I'm looking for y squared, r must be 2. So at this point, you can use an r value of 2 and finish it on your own. But let's also set up number 4 together. Again, I want you to start n. You'll figure out what r is in a minute. Write down, pause the video, n, x, and a. You should have written down n is 4, x is 2m, a is y. So here we go. Now we're going to follow the formula. N, c, I don't know what r is, times x to the n minus r times y to the r. Now, remember, I'm looking for the coefficient of m to the first. So I don't really need to worry about this term here. How can I get m to the first? What does r need to be? If you said r is 3, you're correct, because when I do 4 minus 3, I'm going to get a power of 1, and then 2m to the first will just be 2m. So go ahead and finish 3 and 4 now that we've found the r values, and finish the rest of the page for homework.